so warm up 3.5 today. Warm up 3.5 today is going to be EOC review. The first one is talking about perpendicular lines. Definitely something we have done earlier this year. Make sure that when you record this warm up that you record the date. That's the only thing we record when we record warm ups. And let's go ahead and get you working. First things first, the first thing you need to know is that it says that it's got to pass through the point -4, 1. I'm trying to wait till it connects. There we go. -4, 1. So here's the point that we've got to go through is going to be -4, 1, and we need it perpendicular. That's the key word, perpendicular to this current line. Excuse me. In order to decide perpendicular, you're going to have to do slope on this line first. To do slope, you're going to do what's called rise over run. Draw on your line, get that rise over run on there. How many blocks does it go up? Guys, how much are we going up?
4.
Huh?
4.
I think it's 3, isn't it? I'm just counting blocks. 1, 2, yeah, 3. I just want to make sure I was right. And then how many do we go to the right? 1, and 3 over 1 reduces down to a slope of 3. Now, that's the slope of this line. That's not the slope of our new line. If we want it to be perpendicular, what do we do to 3 to make it perpendicular to that? Perpendicular to that. It's got to be what we call opposite reciprocal slopes. What is the opposite reciprocal of 3? Negative what? 1/3. -1/3. Flip it over, change the sign. Flip it over and change the sign. The new slope is going to be -1/3. Guys, this is the slope of the new line. This is the point it's got to go through. So it's got to go through the point -4, 1, and it's got to have this slope. If it's got to have this slope and this point, we're going to use point slope formula to write it, which is on the formula sheet. We're going to write it in point slope form and solve it. To do that, we'd write y minus whatever our y is right here, so it'd be -1 equals our slope, which is -1/3, that's our m, parentheses, x minus whatever the x here, guys, but because it's a negative, minus a negative turns into a +4 right there. Double negatives turn into positives. Now, notice our equations are not in this format. This is point slope form. These are in slope intercept, so you're going to have to solve it. That means you have to distribute this across. That means it's going to be y minus 1 equals -1/3 x. And then a negative times a positive is going to be a negative, and then grab your calculators. Get to there, and then let's grab calculators. Okay, guys, you're going to type -1 fraction button 3 times 4 equals, now it's going to be a mixed number, so you have to do second fraction button equals. Should give you -4/3. Yeah. Good. Don't erase it because we got that in the calculator. Now we need to add 1, and we're going to get y equals -1/3 x. And then this is already in your calculator, so all you have to do now is hit +1 equals, and what does it give you for that? -1/3. There you go. Okay, guys, so which choice is it? B, yeah. B. Because y equals -1/3 x minus 1/3. Okay, concerns, questions, anything about this before we move on? Okay, listen. Number 2, y'all don't have any idea how to do. It is stuff that we skip. It is only taught in the honors classes, but it is always on the EOC, and this may make the difference between you passing and not passing, or a 4 and a 5. So we try to cover it in our reviews as much as we possibly can. If it makes any connection, great. If not, that's what it is. But we don't have time to go through and do, there's a whole chapter on just doing this points of concurrency they're called. I'm going to go through and talk about them real quick, and then we'll go from there. You need to put all this on your paper so that you have this. A centroid. A centroid is a point of concurrency inside triangles, and it's done every time you have a bunch of medians. medians connecting in the middle. Medians. Okay? A circumcenter is called a point of concurrency inside of a triangle, and every time you deal with circumcenter, you're going to be dealing with the perpendicular, I'm going to write it as a symbol because I don't have enough room, perpendicular bisectors. Perpendicular bisectors. Okay. Incenters are going to be the intersection point or the point of concurrency for angle bisectors. And the last one, the orthocenter. Now, orthocenters are kind of, just so you know, the point of concurrency. It's the most useless point of concurrency. It's not used very often. It's the easiest to remember, though, because ortho is like going to the orthodontist. Anybody ever been to an orthodontist where it's kind of like it's in a circle and the orthodontist is there and all the hygienists go around? I mean, like there are hygienists all the way around in a circle and he just moves from one to one to one to one. That's kind of what the orthocenter is like. It's going to be in the center of a triangle and the people work around the outside. And it connects all the altitudes. Altitudes. Okay. Now, out of these four, look at what these are right here. These are going to have a right angle symbol, and they go from the vertex of the opposite side, okay, from that opposite angle, and they hit at a right angle. Are they hitting at the middle for the median? Does it mark that they're congruent? You can see they're not. This one's not in the middle. This one's not in the middle. Are they splitting the angle? Do they have any marks showing their angle bisectors? Do they show their perpendicular? They are perpendicular, but they're not bisectors. So what are these? These are all what? Altitudes. And because they're all altitudes, this is an orthocenter. Orthocenter. Now again, like I said, if you remember this, great. We're not it takes a whole chapter in the honors class. They hit it. We will not be doing that. But I always like to show some problems with that just in case. If it's that one thing that gets you that extra point, I'm going to do it, guys.